So let me do a quick demo. Here we have a spaceship. I'm just gonna add another one. Just spaceship 1. Let me create like spaceship 2. Let me add real quick here. Spaceship 2. I will change the region a little bit. So this is coming from the sprites. I want to take the next one here. So this is like 200. I just need to add another 200 so it gets the right place there. So now my spaceship number 2 has a new sprite. And then we need to draw it. So to draw it, I'm just going to copy this one. Spaceship number 2. Draw it. Everything should be spaceship number 2 here. Yeah, that's pretty much it. Oh, let's change the position of this one to be 100 and 100, so it's a little bit farther. And the spaceship number 2 is going to be at the center. Build it. And there we go. Now I have 2 spaceships. So now work on the transparency there. Okay, let's move the spaceship number 2 a little bit to the side. Let's make it building. Cool. So there we go. We're going to talk about this 4 things that I've added: camera, instances, sprite mesh, and loading files. And you get this, you can see that we can already render some sprites. So the first thing I added was the camera. I'm using GLM to calculate on the projection and the type of perspective in orthographic matrix. So the projection matrix is this one. And this will output a camera unified buffer object that contains everything that the shader will need to compute. So in the shader part of things, we have the camera, and it's basically the same structure. And we apply this by multiplying the field projection, which is computed beforehand in the CPU, and then to the position of each vertex. Okay, so this is the camera part. Then, when we have multiple entities, we want to render them as instances, okay? But in this case, there's a small optimization we can make, and it's the instance data. So instance represents basically like a group of vertex, or we could say maybe the entire sprites there. And the color, their transformation, the position in space and everything will come from the index. And also, I'm also taking the buffer index because maybe we want to use multiple buffers for vertex and multiple textures. And we need to know which texture we're talking about in this case. This may change in the future where we need to even use multiple textures at once. For instance, maybe we need like a normal map or something like that. But for now, this will work. Let me show how the instance is working right now. It's very simple actually. We have the instance data, and this is what we send to the shader, so to the GPU. And now we have a new draw call here that's just basically telling this is going to be transferred to the instance data. So every time you draw a mesh, the column transformer comes from this. Also, mesh index and texture, they're different. The index and IDs are different. IDs are more like, is where we set up in the scene. We may want to like configure, for instance, I can configure that the mesh library, when I add a mesh, this will create an ID. And the buffer index is different from the mesh ID. which maybe I should change the name to buffer index here. Now let me do this already. It's probably gonna break some stuff. Cool. So for every time we have a draw call, we're gonna generate an instance data object, and we're gonna pass this to the buffer. So for mental, the way we do this, I'm gonna show you here. We have an instance. In this case, I'm using like a page size for the instance, like 120, like 1024 instance in the buffer that can fit there. This should be dynamic and should be able to add more buffers as needed. I'm pretty sure this is not enough for like a larger project or a larger game. But that's what I'm gonna go for now, and later I'm gonna add this feature where it should dynamically grow or add more buffers as needed. So then the buffer is created here. It's just a simple buffer. I'm just naming it, and I'm passing it like the size of the instance data times the amount of instance that I want to support at first. And the interesting thing is that so when we want to draw, for every draw call that we get, let me get to the place here. For every draw call that we have from scene, we will create a new instance. We're so adding a new instance or setting it to the index of that instance, and we can then draw the primitives here. But I don't want to draw at this stage because I still need to set some things. And the way we do this is create another buffer. It's an indirect command buffer, and which is basically a buffer that stores all the draw calls and then it executes all at once later in this command. That's very useful for what I wanted to do here because I wanted to take all the mesh index in the instance count during the draw calls, and this is needed for this type of approach where we want to render multiple instances. So this is, I think this is the core of it. There's here you can see the shader again, the same transformation, the index and everything, takes the projection of the camera, the transform of the actual instance, and then multiplies everything. This is the position of each vertex that is rendered by the GPU. Okay. After that, we're adding textures, right? So texture, we had a debug texture before, but now I want to load a 2D texture, and I'm using the fantastic has2b library that everyone uses. And in this case, I'm loading it from the computer here. So I had to do, I'll show how I did this get data from URI. This is communicating with the host application, so it's cross-platform basically. I need to make sure that it can get the data from either like an iPhone or from Mac or from Windows, from a folder, whatever it is that the host is providing me with a file. Right? Maybe it can even be in synchronous. This should be eventually an asynchronous call that will that runs in parallel, so it doesn't block anything. Not worried about this at this point. Might bite me later if I don't do it soon enough, but it's good enough for now. And so it's just really loading the file into memory, and then here it's like I'm storing it in the vector. Probably not the best way to do it, but I'm gonna start with it, and maybe later I'll change to something more efficient. Then how do we render this? Again, we have like all these textures, types of textures, and then it's just send it to the GPU. The GPU now has all the textures and they're mapped. Every draw call that I have, I'm saying like I need to draw this mesh and this texture. So it maps everything in the shader again. And finally, I think the most interesting part is the scene. And in the scene, we can show, I'm already starting to create some kind of like structure for what like a scene description would be. This is not gonna be like that. It's just hard-coded stuff. But yeah, you can see already some interesting stuff happening here. For instance, I have a list of all the sprites that I'm using in this example. Show you the actual sprites. So have this. So this is the background, and these are the sprites, and taking this part of here. So I'm gonna show how I did that. In this description of the scene, where I have like a spaceship, I have a mesh ID and a texture ID. Here's where we add a new type of mesh called sprite mesh. I have to pass what is the size of the actual image that they're getting from, so it can compute properly the UV mapping, so the texture coordinates, and the coordinates in the file. So like it's 200, 500, it's equivalent to this position here. So it's 200. Okay, so this obviously this is not gonna be hard coded like this. When we create a texture atlas like this, usually there's a file that comes along with it and it stores everything, like where every sprite is located. So this is going to be automated in the future. So here I'm mapping not only the position, so this is just basically mapping the position and computing the texture coordinates from this texture. That's the one that's going to render. And then I add another mesh here that's just using the entire image at the back as the background, so that you can see here from 0. And then setting up some of the camera configurations here. And here, every time I draw, I just clear everything, and then I'm putting the spaceship in the star field there. Here I'm scaling, translating in an identity matrix based on the position and the scale of the spaceship. So this is what will change later is this position. This would make the spaceship move around and everything. This is just a color, so I'm not changing any of the colors. And this is the mesh ID from the spaceship and the texture from the spaceship. There's some room here for like making it easier to use, but I'm not worried about this now. When I get to the scene management part, that's when things are gonna get way more interesting, and you can see the like everything is gonna be glued together, right? So the way we're loading, and there's this part that needs to be cross-platform. So I created this virtual OS class, and I think I'm gonna use this for everything that I need that is a platform dependent thing. So, and I have this code here just to create like an URI and split everything, and it can control like the protocol. But and this thing is gonna be used here, right? So I create this. This is like already on the Apple side of things. So the Apple OS version of that. So it's just implementing everything like that. And so I'm taking the protocol, I'm starting if it's a file protocol because it don't support anything else yet. And so I'll take the host path and inform the file path because it's a file protocol. and then get the file, place it in memory there, and now you can actually use here where we're using this texture 2D, for instance. So now I get the resource data that I need. I check for the size in case it fails or the file doesn't exist, for instance. So this is basically it for this episode, for this update. Things are getting more fun now, and I think this is it.